just going to take the time and kind of review what we've done in the last couple days over class. Okay, so we've classified triangles, we've looked at parallel lines and transversals, and two of the kind of tougher things that we've looked at have been finding the range of a third side, or finding the range of x whenever we're working with a triangle. So remember, the triangle inequality theorem tells us that the sum of any two sides must be greater than the third side. If that is not the case, then it does not form a triangle. So whenever we're finding the range of the third side, or the range of this side x, I just need to write my three inequalities. So the first one means that the first two sides have to be greater than the third. So 4 plus x must be greater than 8. Another one could be 4 plus 8 greater than x. And then the last one, 8 plus x greater than 4. Then I'm just going to simplify. So subtract 4 over, x has to be bigger than 4. Then subtract, or add 4 and 8, we get 12. So 12 is bigger than x. And then subtract 8, and x is greater than negative 4. Okay, so I'm just going to rewrite the middle one to be x is less than 12. Just have the x come first. Now, if x is bigger than 4 and x is bigger than negative 4, the negative gets overpowered. If it's going to be bigger than 4, then it automatically has to be bigger than negative 4. And then you always write your answer as a big inequality with x in the middle. Only use less than signs. Then we're going to put the smallest number first and the biggest number on the right. So this says that x must be between 4 and 12 according to our triangle inequality theorem. The easy route, without having to write all of your inequalities, is to note that you can subtract them to get the small number and add them to get the big number. So for our second example, the difference between 31 and 45 is 14. So x has to be at least 14 units long. And then if I add them together, the sum gives me 76. And so it can't be more than 76 units, or I won't be able to form a triangle. So then that's my answer for example 2. Example 3 looks a little different. Now I want to find the range of x, but I'm given my three sides. So I'm going to have to do like we did for number 1 and write out my three inequalities. But now I have expressions, and then I'll do the same thing where I simplify and slowly get x by itself. So for the first inequality, I could write x plus 2 plus x plus 6 must be greater than 5x minus 2. For my second inequality, I can do x plus 2 plus 5x minus 2 has to be greater than x plus 6. And for the last one, x plus 6 plus 5x minus 2 has to be greater than x plus 2. All three of these must be true in order for it to be a triangle. So I'm going to combine like terms and solve for x. So x plus x gives me 2x. 2 plus 6 is 8, and then 5x minus 2. I'm going to move the 2x over just so I don't have to worry about having a negative. So I have 8 is bigger than 3x minus 2. Add the 2 over. I get 10 is greater than 3x. Divide by 3, and we get 10 thirds. I can't simplify that. Just like we've done before, I'm just going to flip these and make the x come first. So that's the same as x is less than 10 thirds. Okay, put a little divider there. So that's the first one. Same thing for the second one. X and 5x gives me 6x. 2 and negative 2 end up canceling, so I just have 6x on that side. And then x plus 6. Going to move the x over, so I've got 5x is greater than 6. Divide by 5, so x is bigger than 6/5. And for the third one, did it freeze? There it goes. I have x and 5x to get 6x. 6 and negative 2, positive 4, and then x plus 2. Subtract the x over. 5x plus 4 is greater than 2. Subtract the 4. 5x is greater than negative 2. And divide by 5, x must be bigger than negative 2/5. Just like before, if it's going to be bigger than a positive number and bigger than a negative, the negative will always be overpowered. So in this case, because I know it's going to be bigger than 6/5, the negative 2/5 goes away. So I'm just looking at being greater than 6/5 but less than 10 thirds. So I'm going to put the smaller number first use less than signs, put x in the middle, and the bigger number comes second. And there is my answer. That's the range for the possible values of x, so that this is still a triangle. And something else we looked at was the triangle mid-segment theorem. So remember, a mid-segment connects midpoint to midpoint. Okay, a triangle can have three, and they kind of form a little triangle within your big triangle, like this example to the right. We have this little triangle in here formed by the mid-segments. Okay, so the mid-segments are parallel to the opposite side. So this should have little arrows there for us, telling us that they're parallel, and it's also half as long. Okay, so I know that two 3x minus 1s are going to give me 34. Now, these pictures, I'm telling you right now that it's mid-segments, but if you were just given a drawing and it doesn't say anything, they would have to have the dashes to show you that that was where the midpoint was. So if I was going to add the dashes in this triangle, I would say that XA is congruent to AY, so I'd put a dash there. And then on this side, I would put two dashes to show that YB is congruent to BZ. That makes B in the middle. Now I don't know if they are or not the same, so I put two different sets of dashes. Okay, that tells me that it's a mid-segment and we can continue. So I can write an equation that 2 of the mid-segments, 3x minus 1, equals 1 of the opposite side, 34. Distribute my 2, so we get 6x minus 2 equals 34. Add the 2 over, 6x equals 36. Divide by 6, x equals 6. Right? Another option. You didn't even have to write this exact equation. I know because this side of my triangle is 34, that my mid-segment has to be half of that, and half of 34 is 17. And I have another equation where I add 1, divide by 3, I'll still get x equals 6. So you have more than one option whenever you solve for mid-segments. Use whatever comes to your mind first. For the second triangle, okay, these are all three of my mid-segments, and I just want to find all the sides of my triangle as well as this other mid-segment. So if I start with this 3 here, okay, it's going to be half the length of the opposite side, which means that this entire side, YZ, is going to be double 3, which is 6. Then if I go to the 4, same thing, XY is going to be double the 4, so this whole side is 8. And then I'm given that OZ is 5. Well, if OZ is 5, that means that XO must be 5, so then this whole side is 10. And then I need half of the 10 to get to MN, the mid-segment, so my mid-segment is 5. Okay, so your mid-segment is always parallel to the opposite side and half as long. Okay, and the parallel part's important too, but really you just need to make sure you remember that it's half as long.